This is the diffraction lab. I have a laser pointing through a diffraction grating, and it is, as you can see right there, 80 lines per millimeter. And then I basically shot it up against a wall over there. I want to point out one thing here is that, so this is the brightest spot right here, and I've marked it as M is equal to 0. The stuff that I scratched out down here was a former trial that got messed up. So this is the brightest spot. That's M is equal to 0 or N equals 0, depending upon the which time I've actually been talking about it. And then it gets less bright the farther out you go. But there is one odd thing here, is that the spot over here at M is equal to 3 is actually not as bright as the spot at M equals 4. It does get less bright as you go off to the left over here, but over there does seem to be a spot, and not necessarily easy to see through the video camera, but I'm wondering if there's a single slit diffraction envelope accounting for that, but it's hard to tell. I tried different points that I thought maybe a bad spot on the diffraction grating, but that does not seem to make a difference. So anyway, I'll put up a meter stick next. So we also need the distance to the diffraction grating, and so there's the diffraction grating over there. I have it touching the wall, and then over here, and let's see if we can line that up to avoid parallax. You know, as with any of these things, just do the best you can with that, what you're seeing right there. That's too far one way, too far, yeah. That seems to be even. There we go, that's probably the best shot. Nope, there. That's probably the best shot. All right, so I have a meter stick taped up against there, and we're going to do a quick view. I have some shots, some still shots, so for better measurements. So that's M is equal to -4, -3, -2, -1, 0, 1, 2, 3, and 4. I do have 2 meter sticks there. Notice that this is not at 0 over here. And I just arbitrarily chose to the right as positive and to the left as negative. Well, I say arbitrarily, but it's more tradition. And I think that's it. Notice that's about the 10 centimeter mark. M is equal to -3 is between 20 and 30 centimeter mark. That's, I mean, ultimately you're going to do distances. You'll need the distances between the two extremes, over there and there. This is to give a general idea about where they are, because the still shots lose some of the detail. Notice that there is an extension right there, and so that's M is equal to 3. Let's see if I can eliminate the parallax. And there. So we're now at 300 lines per millimeter. As for the next one, we have a similar setup to what we did before. We have the laser, we have the lens there, should be in the exact same position as the other one. And then we're shining it up onto the wall right there. Notice that they are spread much farther apart. One right there in the middle, that's the bright spot. So that's M equals 0, and then 1 and 2, and then -1, and -2 is over there. I will get a much closer look. Give a little bit more detail here. So that's about on that meter stick, about the 90 centimeter mark. And that is just shy of 30. That one's on the other meter stick, in between 70 and 80. That one is between 20 and 30 on the middle meter stick, in between 70 and 80 on the left meter stick. And then that one over there, we will get a closer look. All right, so with the light off, and we can get out of the way. There we go. So that's between 10 and 20 centimeters on that meter stick. I do have those 2 meter sticks lined up about there. And so now I'm going to take snapshots of various critical points. Again, just to give you an idea that we about have roughly a half meter there before I start then 1 meter stick and then the next meter stick. So we've got 1, 2, and then basically 2.5 meters roughly from that end all the way to that end. So now for the pictures. All right, so we are now for the third diffraction grading here, and notice this is 530 grooves per millimeter. As you would expect, the points are spread much farther apart. We have m equals 0 here, m equals 1 there, and m equals -1 over there. So m is equal to 2 and -2 are sort of off screen. They're going to be around here somewhere, but let's sort of step closer. Let's step closer. Give you some idea, between 70 and 80 centimeters there. And then the bright spot in the middle between 70 and 80 centimeters there in the second meter stick. And then the other one in the first meter stick. Give you an idea. So 50, so it looks like somewhere around the 30 centimeter mark on the first meter stick. So we will now do pictures. All right, for part B, we're going to be using Metrologic slide number 5 right here. And so I've got a picture so you can be able to count the grooves in the lab itself, as you will see right there. And however, we need to measure the distance. So what I'm going to do is I'm about to take a snapshot of the Vernier Caliper. So that's coming up next. All right, so there's the Vernier Caliper. It might not look like it's lined up, but that's, I believe, because of parallax. So that should be the distance between them. And I'm going to follow, oh, actually, that probably is still enough right there for you to be able to get a reading from the Vernier Caliper. And again, it's the bottom side right there. That is, as indicated right there, this is the millimeters down below. So it's between 23 and 24 millimeters. The same setup again, except this time using the Metrologic 5 slide right there. All right, and there's the distribution for the Metrologic 5 slide. The grooves are much farther apart than what we were just seeing in the diffraction grading. So these are much closer together. All right, so this is redoing the Metrologic, and it's going up onto the wall. And there we see the dots on the wall. And I've put a piece of paper there. Hey, it looks kind of like a Milky Way galaxy from the side. And I've made marks where the bright spots are for that. So then we'll pull that down and see if we can get some decent measurements from this. Do notice that we have bright spots. It's getting less and less bright. Then we have a dark spot right there at that point. Point it out again. They get a dark spot there and then get slightly brighter. That slightly dark spot, that's the single slit envelope that the double slit experiment is in. Thus it gets a little bit brighter. And so if you look closely, you can see the fact that dark spot and then a slightly darker spot, the next one for the envelope, next one for the envelope, and so on. We're going to stop it there and then come back with the picture. This is the Metrologic 5 data. I put the central spot lined up on the 40 centimeter mark like I did last time, or I guess in the order in which I did it, not the order in which you're necessarily seeing this. The 40 centimeter mark, so that's 40 centimeters right there. And then that's 40 and a half, 41, 41 and a half, 42, 42 and a half, and so on. And so as you work your way down here, recognize that each of these marks here represents a ½ centimeter. And so that is 39 centimeters. And so next thing will be a picture. All right, so for the double slit, I am going to be using that one right there. That's so N is 2. The width of the slits is 0.1 centimeters, and the distance between the slits is that's 0.1 millimeters, and the distance between the slits is 0.175 millimeters. So anyway, it's that one right there, in case I'm reading it wrong. So we have the setup here, as usual, into the Cornell plate. The Cornell plate that I have right here is, I have this upside down from the picture. So that's the slingless slit there, and that's the widest of the double slits over on that side. And so now we have our measurement right there, and I'm going to move the meter stick so that you can actually get better measurements. So when it's straight up and down, that's when the parallax is 0. So right now, I've got that big bright spot somewhere around, well, it's like 60. And then it starts fading off. Doing it again, except this having it shine onto the meter stick itself, and trying not to block the light there. And fortunately, I cannot darken the room quite enough, or from a top angle here. And you want the center of the bright spots in terms of measurement goes. All right, so the next one I am doing is this one right here. So just so you know. All right, so there is where the slot is. Again, it's upside down from the picture that I have in the drawing, but you can see the laser light coming through there. Remember the single slit diffraction, the formula predicts where the dark spots are. So there's the central bright spot right there. And so the dark spot, let's see if I can get a better pointer here. There we go. So there's the central bright spot right there, and that's the first dark spot right there. And the width over on this side, I would say that's actually supposed to be a dark spot right there. Definitely dark spot there and there. But dark spot there, and it should be symmetrical. So there's one there also. And this room is just not quite dark enough really to do this as nicely as I would like. So it's like dark spot, dark spot. So this is the part with the human hair, to give you a sense there of what's going on. Had a nice view. There we go. And you can see that little bright spot there in the middle of the hair. That is where the laser is actually hitting the hair and going around it. And that's what it looks like from a distance. I am rerunning the last one for the width of the hair. So I have it set up again. I made sure that the distance to the wall was the same as we had before. This time I'm putting it onto a piece of paper, and then we will look at the piece of paper to do measurements. And so I will pull down the paper next. Here's the piece of paper where I made the marks for the hair width experiment. This point right here is 40 centimeters. So that's 40, that's 40.5, 41, 42, 43, 44, 45, 46, 47. And so this will give you some idea of where things are, trying to flatten it down so that there's no puffing involved. And also give you a sense of distance here. So that central bright spot is at 40. All the other marks are dark spots. And so there are bright spots. So we have the central bright spot that basically takes up that whole space right there. And then we've got a bright spot here, a bright spot in the middle, a bright spot in the middle. And then we have a dark spot here. So if that's 40, that's 39, 38, 37, 36, 35, 34, 33, 32, 31. That should be 30 right there. And it is, I'm assuming you saw it. Yeah, that's 30 right there. So as you're looking at it, each of these small marks here is a ½ centimeter, and then the tall one next to it is the full centimeter. So from that, you should be able to pull enough data. And I'm going to stop it there.